Suttomo. Hello.
Hello.
Hi, Om Prakash.
Hi, Simant. Am I audible?
Yes, I can hear you. How are you?
Okay. I'm pretty good. I'm rocking.
Great.
So, what I will do is give me 5 minutes. Meanwhile, I'll just share the deck. I
You
guess,
need to share your screen.
yeah, people will take at least 5 minutes to come.
Correct.
So, how do I share?
There's an option to share screen in your window.
Ah, yeah. Do you see my deck?
Yes, I can see it.
Okay. So I'll just be back within 5 minutes. By the time people join, I'll be here.
Sure. Look forward to.
Thank you.
Hello, Om. Good evening. This is Jamshid. And hi, Seaman.
Hi, Jamshid and Rajiv.
Hi,
Hi.
Chintan.
Hello. Good evening.
Good evening. Actually, Om just logged in, and when he saw that none of the attendees are there, so he said, "I'll be back
Yeah,
up."
Okay. Okay.
So we have to wait for him.
Hi,
but I
Aviral.
must congratulate you, Chintan. You took picking all the hot topics of the day.
I guess Chintan is not online right now.
Oh,
Yeah.
okay, sorry.
Yeah.
These are
But
all extremely hot topics.
yes,
Yeah.
definitely.
Absolutely. Absolutely.
So we'll wait for Om to start.
Hi, Aviral. I guess Aviral, you're on mute.
Hey, sorry.
Okay, so I'm back.
Hey, hi, Om.
Hi. Hi, Aviral.
Hey,
Hi, Om. This is Rajiv.
Hey, Rajiv.
hi
Hey, hi.
from Abu.
Hi, Om. This is Jamshid.
Hi, Jamshed. So I will wait for a few minutes. I hope a few more people will be joining.
Yeah, let's wait for a couple of more minutes.
Yeah. So we have Aviral, CK Arora sir, Rajiv Khemka, Seemant and Jamshed.
Yes, that's correct.
Let me send that message to everyone right now. In WhatsApp so that people last minute, there are a lot of people who miss things at last minute. So
Correct. They would be able to join.
yeah. So we'll wait for the last minute and then start.
Yes, let's do that.
Okay. So good afternoon, everyone. Welcome to the session on robotic process automation and artificial intelligence. And today I see we have Sanjay Gupta, Aviral, CK Arora, Jamseed, Jeff, Rajiv Khemka, and Simon. So please feel free to stop me at any given point of time during the presentation. If you have any question or you want me to go through something again, so we'll take some time and go through it. And let us start the session now. So let me take you through the agenda of the session today. So we will look at a brief on what do we mean by automation, what kind of automation we have, then why do we need automation, and what market thinks about it, what people are doing in the market, who all are adopting RPA when we talk about robotic process automation, who are doing what, and which industry segment, what do we mean by service delivery automation, what kind of automation happens in that, who are the platform vendors who are supporting these automation, who already have created some systems, and then we'll look at some of the use cases, specifically banking use case, which most of us would be able to relate to because we all are banking customers. And then we will take a look at how RPA and cognitive computing can be applied into different areas. What is machine learning? Then we'll also look at, what is the journey? What is the reference of creating a robo? What is the bigger picture which people are trying to incorporate, embed in systems with respect to overall capability landscape we are building, and then what kind of intelligence we have in computing, some of the learning resources which will be useful for all of us that I'll share, and then we'll go over question and answer. Does this look comprehensive? Did I miss out anything? Anything which could be added, removed?
I think this is very comprehensive. Om, let's start with this, and along the ways, I guess there would be questions which
Sure.
we can, focus into. Yeah, please.
So when we talk about RPA and AI, I would like to give a distinction here, and the distinction is in the image itself. If you look on the left-hand side, it's more mechanical, it's more action-oriented, it is more to do with the rules, a certain composition of a machine to enable itself to do certain kind of tasks. If you see the bottom one, a robo is being trained to draw something on a drawing board. So this is the left-hand side of it. On the right-hand side, if you see, there are models of brain. So brain thinking all that comes as prominent distinguisher when we look at the right side. So when we talk about RPA, we talk more about the left side of things, where functions, processes, systems, which are there in a business ecosystem or an IT ecosystem or whatever ecosystem we talk about in terms of services we offer out of those systems. So they are composed, and basically we code rules to automate them. When we come on the right side, where the intelligence is there, it also enables us to think and then act, decide on something, analyze something, create a pattern out of something, try to predict something. So those kind of capabilities would be powered by something which we known as intelligence. And because this is artificial, God did not create it, we humans are creating it. That's why we call it artificial intelligence. So that's the distinction between RPA and AI. Now, the world is fusing. So these robots are also having these capabilities. So slowly, from robotic, pure robotic, rule-driven automation, we are moving towards something called cognitive automation. Some people call it intelligent automation. Some people call it learning systems. So different terminologies are there, buzzwords are there in the marketplace, but this is the fundamental distinction between the two. Now, if we look at, I don't know, how do I hide this? 1 second. Huh? Yeah. So as I spoke about two types of automation. One is robotic automation, where either in part or full end-to-end process is automated, and that process is otherwise done by a human. So whatever work a human does, are we recording this session?
Yeah, this session is showing as recording because on the top bar it is showing as recording.
Okay, fine. So if somebody is recording, it's fine. So these work, these works would be otherwise done by human. So that would be the robotic piece. The more and more intelligence we bring in, and more capability like recognizing pattern, classifying objects, classifying data, classifying things, and decide and act kind of capability, prediction, analysis, and those kind of things, it moves towards intelligent automation. Now, intelligent automation, one fundamental distinction is beyond these capabilities, what I spoke just now, it has a self-learning capability. So it can learn based upon the actions it performs, based upon the data it interacts with, and based upon the behavior it is run with. So it gradually improves itself, and then there are learning algorithms which are embedded, which actually enables it to think. And that comes in the zone of machine intelligence, neural networks. There are certain cognitive computing technologies, natural language processing abilities, and those kind of things we see. Now, entire automation landscape, be it any type of automation, it fundamentally operates on data. The data can be structured, it can be unstructured, it can be linear, non-linear, time dependent, or time independent. So these are the various types of data we have in the entire landscape of computing on the entire planet, and all these automation essentially operate on some sort of data in a particular context. Going forward, so if we have to basically create a matrix, what kind of automation are possible, what kind of automation we have been doing. So there are human-based automation, certain things which is non-repeating, manual kind of effort. So the automation index, we can say 0. Why? Because it is manual. Then there are rule-based automation, which is scripting. So we script something, we know that this is linear, end to end. We have to execute it in a repeating manner more than 20 times a day. So we know we have fixed set of variable parameters in the entire process. So we script it, and we have been scripting it right since 1970 in mainframes, in mid-range computers and other computers which evolved further. Then there is orchestration of activities. So from task based, it becomes activity based. So consider creation of WBS, work breakdown structure, is a task. Project management could be an activity. Within project management, there can be sub activity like requirement specification, those kind of things. So then it came orchestration. So here a set of tasks, the complex, sometimes standard. So basically we compose a set of tasks in a particular context to call it an activity, and we track the activity. So this started happening, but still it is rule based, little complex, but we started having a script of a script. So we started composing and organizing things into different modules, different sections, and then it started automating. After that, there is a term called autonomics, where process-based automation came. So these are non-standards. Contextual, these are again contextual, and it has inference capability, decision-making capability, it has observation capability. Based upon certain baseline parameters, it would act. So then we had those BPM systems and things like that coming in, and RPA also falls into that. After that, the last level of automation is knowledge-based, where self-learning capabilities started coming in. Then it started having capability of analyzing data and doing some predictions. So that is where machine learning came. Now, if you look at the outcome, as we move towards right, the labor quantum started going towards zero, and intelligence quantum started increasing the more we move from left to right. Now, why do we need automation? Now we need automation to basically, there are certain benefits, cost benefit, quality benefits, value realization, and ease of managing business. Now, we do not have to re-engineer any process when we talk about robotic process automation. We experience immediate improvements. We can allow local variation in the process, geographical variation, one process running in different geographies that can be taken care of. We can quickly deploy it. And there are challenges, of course, in any automation. People look at return on investment. When scope creeps and complexity comes, then that is another challenge. And then when we try to automate poor process element, like, we are not getting much advantage, the process is complex, we know how to do it in a lesser time, but still we try to automate. So those kind of automation should be avoided. So that is a challenge. Like, we cannot automate eating. So if eating gets automated, what value we are getting? Nothing. I mean, better we eat ourselves. And then managing exceptions when they occur. So this is another challenge which comes. So these are the advantages, benefits, and challenges. Now, what is the market view? I think there is one thing which is, anyway, that's repeating, but it's okay. So market, if we talk about digital transformation, in last 3-4 years, you would have heard of experience, UX, CX, customer experience, user experience, interfacing experience, and whatnot, all types of experiences. Now, market and industry, by and large, have come to a place where experience is not the primary driver for any business. It is the operations capability, how efficiently, effectively you can operate. So operations have taken more priority than experience. So experience is now is called a function of operational capability if we are able to operate effectively, then we should be able to create and deliver richer experience to an end customer. So that's the kind of thought process which industry is moving in. So the digital transformation across industry segment will focus more on operation and then create experience for the customer. So there are certain industry data which I have collected. CIO journal says that this automation can actually create a large impact on operation and creating more capability in the operational capacity of a particular segment. So market is expected to jump from 183 million to 4.98 billion. So it is a huge leap if we look at automation opportunity. 45% of activities in individuals perform can be automated by adapting currently demonstrated technologies. So we do not have to basically reinvent certain things, and we can automate a large segment up to 45% what humans do. An RPA software robot is capable of performing a list of more than 600 actions in a given sequence. This is phenomenal because a human cannot do more than 10 actions in a given sequence. Even 10 is a good number for a performing human. And robots can do 600 actions in a given sequence. So that is going to save a lot of time and effort what we do. And then by 2020, this industry is going to have CAGR of 60% worldwide. And there are certain things which are prerequisite, which I have mentioned here. I'll be talking about it later as well. So a cognitive piece is going to come into this entire making of operational efficiency and enhancing operation capability. And that relates to building process knowledge, related knowledge base, using knowledge base in combination with business rules and things like that. Machine learning is going to play an important role. And any high volume repeatable admin type, fault remediation type of things will actually increase the operational efficiency and powered by RPA, AI, and technologies like that. So if we look at RPA adoption across different segments, human resources, procurement, sales, so this is the landscape which is there. And this was done by, there is a company called HFS Research 2016. So they have intelligence operations study. So starting, they hit upon IT and network ops. So SOX and NOX, what we usually know as. So there 10% is full scale RPA done. Remaining 23% is in progress. And then finance and accounting 6% has been done, marketing 10%. So if you look at the pattern, less than 10% is done and 20% is in progress. That means there is 70% is still to be done. And out of that 70%, I guess on a scale of 100%, 30 to 40% opportunities is still untapped. So this particular area is going to churn lot of work, lot of automation related projects and things like that. The platforms itself will mature and scale. There will be mergers and acquisition in the marketplace to win the particular segment. Like finance and accounting will have a different platform segment for platform vendors to play, whereas sales will have a totally different strategy to tap the market. So when we talk about service delivery automation, there are primarily two types of processes we see. One is because in no industry, no company, no enterprise is a business enterprise today. All of them at some point of time, in some way or the other, either self capability or augmented capability or bot capability, they rely heavily on technology. And when I say technology, it has to have IT systems, IT operations, IT infrastructure, their own IT capability. So IT process is one big segment for automation, and this powers business processes, enhances, directly impacts business capability of an enterprise. So that is the end goal. So these two landscapes are distinct in the marketplace. So it starts with automation of network, server, storage, DevOps, cloud infrastructure automation and things like that. And slowly it goes towards IT services. And at the top layer, you have business services, which we deliver to the customer. Any questions so far?
So just wanted to understand one point over here, Om, is in terms of, if you look at the cost of deployment and typical timelines that go into development of IT automation, do we see RPA, impacting positively on both fronts? How is it?
Yes. So let me take you a little back. Let us consider a requirement which needs to get into an application, and it has to follow typical SDLC model, which is software delivery life cycle. And then finally it goes live on a cloud infrastructure. Now, right from the beginning till end, if I have to automate, so let me go a little deeper into what do we mean by automate. So I have a requirement and I have a code, and I have to have a runtime to run that code, and then some interface I have to expose to the customer to experience that the requirement is realized. If I just have to automate this end to end, and as I add code, as and when I add code, in the same pace, customer can see the requirements being realized. So the pace of adding code and pace of requirement realization by an end customer who will be paying for requirement realization, if I can map these two pace, if I can bring it closer, like every day, if I'm adding code, every day customer is seeing requirement realization. If not every day, every 2 days he should see. If I can bring these two together and balance this, I have no other way than to automate things.
Understood. And what would be the impact on typically the cost in terms of traditional IT automation development and the one that is implemented through RPA?
So cost I will come towards the end. In the Q&A section I'll come, because that's a little vast range of things are accounted there, but I'll come there.
Okay, thank you. Thank you.
Okay, so what are the platform vendors which actually, so this is the landscape, IT process, business process, and these are the services which we create. And then there's a value complexity range. So what does that mean? So automating an IT task is simpler thing. Automating a business service is more complex, but automating a business service gives more value than automating an IT task. So that's what it means. Now, if we look at platform vendor landscape, who are the platform providers using which? And that will also relate to the cost, because a platform cost is the first cost which we basically incur. So there are four, we should look at the whole thing from a 4-quadrant perspective. So on one side, there is front office automation. On the vertical side, there is business automation, then IT ops automation, and both these automation has front office automation, back office automation. Now, let me give you an example. In an IT operations scenario, L1 would be where the method to reach L1 like call, IVR, chat, then search, ability to log a ticket, problem ticket. Those are front office automation. On the back office automation, it would relate to monitoring a network device, remediating a problem in a particular server,
backing up a database. So those would be back office automation opportunity areas in IT ops. Similarly, on the business, front office would be customer facing, back office would be back end business processing. So if we look at these four landscapes, now automation anywhere, work fusion, UiPath, and few other systems, they are more business and front office centric. Business and back office centric also you will see these tools. So with different capabilities. So UiPath is at both the places, and then Blue Prism we have, and then we have Automation Anywhere and few more. On the IT ops, the back office, we have IPsoft, Arago, IAHU, and Atomic. And on the front office IT ops, we have BMC, Petrol, ServiceNow, Microsoft, and Atlassian, Jira, and all those tools. So this is basically a comprehensive distribution of different platform vendors as per their applicability areas. Now, some of the banking use cases which we have been working on, which we have worked upon, which can become a candidate for robotic process automation, and banks are doing it. Most of the banks are doing all these automation: customer engagement, personalized customer advice, financial advice, onboarding, tax reporting, tax reclaim. So end-to-end risk management, fraud detection, the corporate function, remediation, reconciliation, vendor management. So end to this actually covers the entire landscape of a banking business. So end to end, it has business in it, it has IT ops in it, it has front office in it, it has back office in it. So end to end things are being automated by different departments of a particular bank. We are working with a few in this automation, and then the advantage is huge. So I'll give you an example. We have a customer where they used to have 200 people working for 365 days to basically process the back end invoices and those finance instruments. And the error rate was 6%. And the 6% used to cost almost 600 million to the bank every year. And to cover this 600 million, bank used to put some 100 or 200 million to reduce this up to within 100 million or 150 million. But the loss was never less than 100 million a year on these errors. And those errors used to be carried forward every year, and it used to compound every year. So that is how banks actually lose credibility in the marketplace, and that becomes NPA after some time. So after automation, the error, human error, from 6% it became 0.6%. So you can see from 600 million, we brought the loss, the scope of the entire loss, to 36 million. So that was the basically jump which they saw within a year time. And then number of people who used to work was 200. Yes, we can say that there will be job loss, but these people can be redeployed into higher value chain work rather than doing the redundant monotonous job year and year for 15-20 years. So from 200, they reduced the manpower within a year to half, so 100. And then now these 100 are also not required. Only some 10-15 people are required just to handle things here and there. And they are planning to reduce it to 50 now. So 150 people, 365 days, that cost itself is a huge cost. So to give you a cost, now coming to the cost, because I have already touched that topic, 1% doing the job full time every year, let us say that cost is X. If I automate it, the cost, average cost becomes X by 6 to X by 3. So the maximum ROI you can have is 1 minus 1 by 6, which is 5, 6. 5 on 6, the minimum you will save 2/3. Sorry, I said it reverse. So up to 2/3 you can save, starting from 1/6. So the minimum saving will be 1/6. The maximum saving will be 1/3. That's the pattern which we have seen. So if you are spending $100, minimum you will save would be $16 to $17 if you automate every $100. Maximum you will be able to save $66.
Om, this is Rajiv. Just one quick question. When we say we are eliminating the people, substituting the people with the robots, let's look at the customer onboarding process in a bank. How exactly what are the activities which a person is doing which gets replaced by a robo? For example, a person may be seeing the filled up form, application form of the customer, and then entering it in a computer system to onboard the customer. How
that gets
that
automated
process?
That gets automated. So you have a machine like ATM where you can insert notes. Suppose you have now you have a machine where you can insert your A4 size form.
Okay, understood.
So and then it automatically gets read and entered into the system. Now there has to be someone who validates it. So validation versus entering the entire form is two things, right? Validation takes hardly 10 seconds or let us say 1 minute, but entering the whole form will take half an hour or 15 minutes.
Right. And entering is also prone to more mistakes of typos.
Exactly. So there are a lot of advances which is happening. Let me give you an example. I went to a hotel in US. They have adopted, so that's a Hyatt chain. So they were doing some pilot with a company. So they were automating check-in and check-out process. So what I had a sheet of paper where the bank, I had booked it online. So in that sheet of paper, I had a barcode. I don't have to talk to anybody. I just have to scan that barcode in the system. It will do something for 30 seconds and then give me a card. That card will have the room number. That card will have the access key. Now, and it also has, the direction element. How do you go to that room? So just by looking at that card, I could reach my room, open the door, and then get in. And the end-to-end time took 1 minute. Now, anywhere in the world, if you go in any kind of hotel, premium hotel or whatsoever, 1 minute check-in is not possible. You enter your room at least 10 minutes afterwards.
That's a very good case, 10 minutes.
Yeah, 10 minutes is a very good case, yeah. That fellow will check what not, and then automatically my credit card is charged. And the moment I check out, it knows how much it has to charge and how much it has to refund or whatever it has to do. It did that, and that's it. No human error.
So, what about the typical security ID verification, like checking your passport, etc., etc.? So,
okay, so you have to put your ID. So I had to put my passport there. So it scanned the passport. And it verified whatever it had to verify, that only I have booked the ticket and it's not the other person. It did all that verification and I was good.
Wow, that's really very good use case.
So people are coming up with a card. So now I'll tell you what is happening. So people are coming up with a smart card, which will have every damn thing in terms of your identity. It will have your country, it will have your passport detail, it will have your Aadhaar card. You can put your driving license, whatsoever you have in terms of identifying yourself, your address proof, your telephone bill copy, recent 5 months or recent 6 months, your bank detail, every damn thing will be captured in that particular card. And wherever you go anywhere in the world, one of these will be valid. So it will know whether you are having a valid identity or not.
Amazing.
and this will be on the server. So, and this server will keep on updating because people keep on changing, address people. So you will have one interface where you can update your detail with 2-factor or 3-factor authentication. You receive a, OTP kind of thing, and then you do a fingerprint, etc. And then your identity is secure there. Once that identity is secure, and then there are secure interfaces to interact with it, your identity gets verified anywhere in the world.
Correct. And even in the case of the hotel check-in, one can do a biometric scan so that, tomorrow you might need not actually give a scan of your passport separately.
Right. So for business visitors, see, for tourists, they have a lot of time. But for business visitor who checks in the morning, checks out in the evening, if you take 20-30 minutes out of his time, then he is in trouble,
True. Very true.
So it actually helps the business traveler, the frequent travelers, frequent flyers, and things like that. You don't have to wait in the queue to do your online check-in. You just do online check-in and then put a tag and then put the things on a platform where it will take your luggage, everything, and then it will deliver to your hotel. You don't have to pick up your you don't have to wait in the queue on airport you have to wait for at least half an hour to get your bag, right? You don't have to do all that.
So
Bag
Om
will
Prakash,
reach much before.
Om Prakash, coming back to this banking use case, the
Hmm.
fraud detection use case, how is the RPA based fraud detection different from, let's say, a software and analytics based fraud detection where patterns are
Okay.
identified and you are flagging out a possible fraudulent transaction either on a credit card or in a banking account where there is a transaction which is out of line with the normal trends?
Right. So you do hot scan, you do different types of backend systems are there to
Right.
do a fraud detection, right? Or detecting a bad guy and things like that. So now, how do you integrate it with the front end? So that is where RPA comes in. What kind of actions do you take? Now, usually, if you go in the bank, there will be 3-4 guys who will be acting on these fraud detection. And they will also alert the front office to release a payment or not release a payment. So there are multiple systems involved in this. Multiple screens, they will be logging into multiple screens and transferring data from one to another. So all those things are done in an automated way using RPA.
That's amazing.
So when it comes to integrating different types of systems and not following, the protocol of software integration, how do you accomplish things in a UI way? That is where RPA comes in picture. You don't have to share the login. You don't have to store anything. You just have to, record once and it will keep replaying that. Okay, so there are different areas where we apply RPA and cognitive computing. So in operational analytics, in autonomics like self-service bots. So this is not a very new concept. It's almost a year now. There is a concept of self-service bot. What it does is you go to a website, you submit whatever you have to submit. Like suppose somebody has to do insurance claim processing. So he just uploads certain documents and then it automatically locks a ticket, goes to the backend agent. He does whatever he does and this guy gets notification. And then at any given point of time, if he is not able to get the notification, he can check the status using the same bot on the same website. So the bot becomes an interfacing agent between the customer and the back office. And whenever the process is complete, this guy gets notification at the completion of each and every step. And then he knows that where I am, when I will be getting the refund. And if he has to submit some additional document, the same gets done through this bot. So this bot will reach you, you upload the document, it will again put it in the same file where your claim is getting processed.
So Om, is this all restricted to companies overseas or companies in India are also started to do this?
Companies in India also started doing it. You will have certain things coming in with Intel. You will have something with Airtel. Then I guess this guy is also doing a good job in terms. So a lot of bio research firms, they are doing this using fingerprint and things like that. So there are a lot of applications which are happening in terms of medical report reconciliation and things like that. So lot of software driven automation as well as robotic automation with artificial intelligence, pattern matching, all those things are happening. So in India, I think it will take little while. Maybe a year down the line, you will start seeing all the banks having self-service bots. So you will go, there will not be a beautiful lady welcoming you. There will be a robo saying namaskaram to you. And that robo will have options. It will display 1, 2, 3, 4, 5, what you want to do, and then it will direct you to that direction. If you want to draw money, it will direct you to ATM. If you want to go to a teller, it will direct you to a teller. And that teller will collect some information and then scan things and automatically release money to you. It doesn't have to do manual verification. Makes sense?
Yeah, makes a lot of sense, and also scary.
Scary, yeah. Scary because there are a lot of unknowns involved, and we human beings are scared of unknowns. So when we come with machine learning, so there are two types of learning when it comes to computing and when it comes to human beings as well: unsupervised and supervised learning. In supervised learning, we have decision pointers. So when somebody is learning, we say that, okay, fine, you learned this much, now you can draw this decision. And in unsupervised learning, it keeps on doing in an unattended way. And then there is feature extraction, what action it needs to do. And there are learning models which actually are predefined models, that if you have this much data, you can do this prediction or take this action or make this decision. And those things are, then there are grouping of objects, and then there are predictive model. There are different types of learning models which are there. If you that will be the subject of machine learning algorithms. So finally, what it does is that it enhances one's capability to take decision and take action. And it all operates on data, patterns, models, and it tries to retrofit the learning with the model. And once the model is complete, then you have one feature to be delivered. So statistics, probability, and cognitive computing theory, those are the ones which, if you are interested, you can search for these and then get some handhold on machine learning.
So a question over here, Om Jamshid again.
Yeah.
Between machine observation that you mentioned earlier and machine learning, if we were to look at this slide, is there any part of it which gets covered under machine observation?
See, machine observation, that is, there is twofold of it. One is it observes what actions I am doing, and then there is, if there is any action which is not matching the previous action, it will depict an error. So that is the part of observation. It doesn't learn anything. Whatever actions are happening, if there is any exception condition, it will detect an error and then it will report an error, notify an error for a human intervention. The other type of observation is that if I see these images, suppose biometric fingerprint or face recognition and those kind of applications, or voice recognition. So the moment I see something exceptional, I will just have comparison capability. So comparison, when somebody does a comparison, it's not learning, it's observation basically. And based upon that observation, you compare and report error. When it comes to learning, it actually doesn't do only comparison, it also tries to fit a model where if A, B, C, D are done, then I can call this as X. So it doesn't have a reference. Whereas observation has a reference to compare and then report error. and the applicability is limited. But when it comes to learning, it can learn anything. It all depends on the possibilities are endless.
Understood. Thank you.
So this is the human brain, your brain, my brain. It has 7 levels, 7 layers. So sensational process, memory process, perception, action, metacognitive, meta-inference, and higher cognitive processes. Now, higher cognitive processes are your comprehension, learning, problem solving, decision making, creation, planning, and things like that. And at the lowest level, what you said about observation is vision, audition, or maybe first three can be observation actually. We'll take a look at layered model of brain. So where AI is moving is mapping all these capability into a robot to make it look like human. So the way human comprehends, robo can comprehend. The way human learns, robots can learn. The way we solve problems, robots solve problems. So this is the AI reference, artificial intelligence reference, which is being applied in bits and pieces in a particular context of a business process. Yes, somebody was asking me some question. Hello. Am I audible?
Yes, you are audible, Om.
Okay. So I'm coming to the end of it now. So when we apply this intelligence in computing, like let us say chessboard or any particular game, we perceive, we cognize, and then we take action. What are the actions we take on a chessboard? Best move, shortest path, and all that, right? So these are some of the things. Robots are also trained with a model to take action. When it comes to systems, what are these capabilities, what are these cognitive capability and intelligence capability are OCR, ICR, where you optically recognize a character, then you recognize face, you recognize speech, image, then you diagnose a particular problem, the natural language processing, reasoning, all these things start coming in the business application domain. Knowledge representation. One example can be email spam filtering. How do you recognize that there's a spam, there's not a spam? So those kind of capabilities, when we try to build and behavior-based robots and intelligent agents, intelligent control, when we start inserting, then things go in a much more intelligent way, and then there are many more business services possibilities which come into action, and the sky is the limit. And that's why people are afraid of this. Now coming to some of the learning resources, people who want to learn machine learning. So there is a Java machine learning library. Then there is a Veka library, which has certain examples. It has certain models in Java. Now, people who are interested in exploring something on RPA domain, they should know Java, Ansible, Unix, Python, etc., etc. There is a IRPA and AI, which is Institute for Robotic Process Automation and Artificial Intelligence. The membership is free. You can go there, you can register yourself, and then keep receiving updates, latest research, some webinars also they conduct sometimes, some events, etc. And on the machine learning API side, we have Amazon API, we have IBM Watson, Google Prediction, and things like that. So these are some of the learning resources which I'll share with you, and you can take a look at it. And then if you have questions, we can take the questions. If you want to know about me, I have put my LinkedIn URL, and there's a blog where I have few articles, few related ones, and then you can take a look at it. So with this, I come to an end of this session, and then open for questions.
Yeah, thank you, Om. I think this was a really good insight and intro into the world of RPA and machine learning. Just to kind of, understand more from a perspective of machine learning and, on our tech chat, WhatsApp chat, we've been talking about how AI has developed their own, language, and then the MIT guys had to shut the AI down. So,
Yeah.
as you rightly mentioned, that definitely in humans the fear of unknown is the greatest. And given that now that we are looking at things, they move in a pretty much exponential manner, and things can kind of get out of perceived control, so to say. So, if playing the devil's advocate out here, what is it, and what are the risks involved with respect to AI in specific when it comes to the larger canvas of the human life?
Okay, so one example I can give you, taking back to that example, as long as these systems, these learning systems do predictable things, humans are not afraid. But the moment it starts doing something unpredictable, like you train a robot to, let us say hi to your girlfriend, and this robot you have deployed as a security guard, then it is a predictable thing and you will love it. But when this robot goes out with your girlfriend without telling you, then you have a problem, right? Because that is an unpredictable behavior.
Correct.
Right now, robo is looking at you every day, that you I mean, this girlfriend comes and robo welcomes the girlfriend, and then the girlfriend goes and meet you, and then you go out with that girlfriend every day. Now if it starts learning and starts applying the same thing what you do, if robo starts doing it thinking that it is going to help you, it is going to, because the fundamental is what? The fundamental is that your work reduces, right? So robo thinks that by taking your girlfriend out without telling you is reducing your work, is helping you, but that is unpredictable, unwanted from your perspective. Now, how do you define unwanted learned, I mean, unwanted decision and action taken by a robo? Because the number of unwanted things are limitless. Number of wanted things are limited. So that limitless zone, when a robot tries to explore, you are in trouble. And because you have made it open-ended, it is learning itself, you can't stop it. You can stop it by powering it off, killing it, but otherwise you can't stop it. So robot is thinking that it is doing you a favor by taking your girlfriend out, whereas you don't want that.
One would introduce in the AI ecosystem system.
Hello,
Is there some
audible?
framework established to ensure that? Hello?
Yeah, did I answer your question?
Yes, yes. Thank you, Om.
Yeah, you were asking something else.
Yeah, I was saying that is there some framework or model that is established to ensure that the AI remains in the control of the humans, and it works in the predicted parameters?
Yeah, there is. But when you leave it on an autopilot learning mode, unattended learning mode, That's why there are two learning modes. One is supervised learning, and then another is unsupervised learning. Now in supervised learning, you have opportunity to create those boundaries. But in unattended, unsupervised learning, you have no opportunity to define its boundary other than setting off the system. That is why when you leave a robo on a teller, it will do more error.
Understood.
Because on a teller, there are random scenarios. There are so much of variation, which you do not want. So that's why people are afraid that whether it will do the right thing or not. Fair enough, it read the check amount and then disbursed the amount. What if there is an error and it still doesn't recognize that error and disburses more? And then there is no way to catch it other than in your monthly statement report, and by then you might get bankrupt. You never know.
Correct.
Or you have so much of problem to deal with that you have to close your operations and then deal with those exceptions which robos missed out. And from a rule perspective, from a coding perspective, from a automation perspective, all those scenarios will look quite genuine. So people do not know what are the uncertainties which we can introduce in a robotic intelligent system, and that's why people are going a little slow about it, and then people are afraid about it as well. The fear is not coming from the loss of job, because there will be more jobs created when AI comes. I mean, in full swing in all business.
Correct. True. So CK,
And as humans, we need to have controls. We need to have things which we want, and do not get engaged into things which we do not want, because the damage being created will be huge. And it will be repeating damages. I don't know, possibly shutting down that robo will also not help at times, because if you shut down the robo, your usual tasks are gone for a toss. So where do you stop? People do not know about that. That's why there are a lot of apprehensions and things like that. But I hope with all the wisdom on the planet, we should be able to make sense of, make use of artificial intelligence for human purpose, which drives our purposes, objectives in lives.
understood. Understood. Oh. So can we have some more questions? CK, Jeff, Kanwal, Rajiv, Sandeep, Sanjay, any questions that you would like to put forward?
The session has been very, very informative. Thanks, Om.
Yeah, Om,
Thank you, thanks.
This is Rajiv. This has been a very, very informative session. Now, typically, of course, that may not. And are these RPA projects being taken up by, let's say, banks, more in the shared services area by customers?
No, it's at both the places. I mean, their units are also doing it. Some places they are tying up with vendors like TCS, Wipro, company like us, and then doing it. So it's not only shared services. These are, I would say, more innovative projects than, as transactional as shared services.
Okay.
So Om, we have got a question in the chat window from Kanwal. His microphone is not working, so he has written, which states, on the fraudulent use case, we discuss on the RPA use case for integrating back office system. Isn't this entering the EAI area of having various systems, whether back office or front office, to work in integrated manner?
Yeah, you can say that it's a larger EAI with RPA, but it's not typical EAI where you create queues or create channels to integrate a front-end system with a back-end system. What essentially the differentiator, what needs to be seen is which front-end system, which back-end system has to integrate with each other. If that is not fixed, because AI will fix it out. So if you have to go to three external system, if you have to also compare from website, so then how do you integrate it? You can't integrate with all the websites. Come on. So in that case, RPA knows, and RPA can help basically integrating all that and giving you the final outcome which you are interested in, rather than putting years in an EAI and then doing it. See, that's the advantage, you know. Everybody knows that BPM can do every damn thing. It can integrate with each and every system. It can honor everything. But what can it automate the job of BPO? So then BPM led to BPO officers, right? And then it again started. So nothing was automated. If things are automated, then the number of people should be reduced. But that didn't happen. BPM led to BPO. Number of people started increasing. Still manual reconciliation, verification started happening. So RPA helps where a thing is done by a human to mimic a human. So which is not integrated thing, but kind of initiatives and projects. Whether I answered this question or not. Kanwa.
So
Okay.
Kanwa has messaged that yes, he got it. He's thanked you for it.
Right, thank you. So with this, we end the session. I'll share the PPT and recorded thing. I guess Chintan will have access to it.
Yes, so Chintan will be then uploading it on YouTube. And
Yeah.
thank you once again, Om. This has been a wonderful session. And I would request Rajiv Khemkaji to propose a vote of thanks.
Oh, thank you. Thanks.
Om, I would say this has really been a very interesting session, because I have been reading up RPA on my own for the last month or so, and I became a member of the RPA Institute also. But I had whole lot of nagging doubts in my mind as to how the whole thing works, particularly around how you are automating away what really people are doing and how you are putting that into a robotic framework. And I think you have explained it all very beautifully in such a short time, and you have given all the concepts. So thanks to you. And just out of interest, I may reach out to you again to
Certainly.
for broader discussions. But I think really it has been a very interesting session. And I know while Chintan is not here in this forum today, I would like to also extend my thanks to Chintan also for taking the lead and getting us all on this forum. I have just kind of just started participating, and it's really been very amazing. And I find the speakers are really very knowledgeable. The last week was also very interesting, and so is this week. Amazing.
Thank you. Thanks, Rajiv, and thanks everyone.
Thank you, Rajiv ji, and thank you, Om.
Thank you.
Bye bye.
Bye bye.
Bye.